Let's take a look at how we can recreate this flower particle blooming type effect inside of Houdini. So I recently saw this effect done with XParticles, which is a plugin for Cinema 4D, and I thought it was pretty interesting, so I figured we would remake it inside Houdini and just see how they kind of compare, and figured it'd maybe be a little bit useful for people that are maybe looking to see how things work inside Houdini, and if they're trying to jump over from Cinema 4D, this might help them out. So this project file will be available on Patreon. If you'd like to grab it, you can do so on there. But let's drop down a SOP create and dive inside here. And I'm going to start off with a circle. And we're going to spawn points, or spawn our particles onto our points. So I'm going to set this to an open arc, and the divisions we're going to set up to 100. We can change this later, and we will, but we'll leave it like that for now. Now we're going to take the normals of our points. If we select this, we see that we have no normals. So we need to give them some normals, and we're going to use those normals to drive our velocity once we're inside of our popnet. So we want to have our normals pointing away from the origin because that's where our sphere or our circle is placed. Before we do that, let's drop this uniform scale down though. Set this to like 0.01 for now, and zoom in a little bit there. So let's drop down a modify normals node, which is the node, one of the nodes that's available on my Patreon. All you need to do is just make the normals point away from the origin. It's a really easy way to do that is with this node. So we can use normals pointing away. And you see our normals are now pointing away from the origin there. So I'm going to just disable that, and we'll drop down our popnet. We'll dive inside here, and let's start with this pop source node. So we're going to change our emission type to all points, and then we're going to set our birth impulse activation to be $f == 1, and that makes it so they only spawn on the first frame. So we'll skip to the next frame, and you see that that shuts off. Now we'll change that for a couple of pop nets. We're going to make a couple instances of this pop net. You can do it all in one, but it just adds a little bit of complexity to it, and it's just not worth the extra complexity. Just struggling to get some things to actually align properly. So I figured we'd just make it in a couple of them. But we need to enable this just born group. So we'll just put JB in there, or just born. And then we need to start dropping down some nodes to actually affect our particles. So first of all, we're going to use a pop VOP. We'll dive inside here. And as I said before, we're going to take our normals and we're going to pipe those into our velocity. But first, let's do a multiply constant just to give us a little bit of control over this. So I'll wire that into our constant and pipe that into our velocity. Now I'm going to change this from 1 to like 0.1. It's just a value that I found that works quite well. So if I press play now, you can see that we are getting our particles moving away from our origin there. Now, I also want to store what frame these particles are being spawned on, because we're going to use that for a couple of different things. And also, it's just a good thing to know inside Houdini. So we'll drop down a bind export node, and we're going to come in here and take our frame, wire that into our bind, and we'll call this birth frame. So let's bump up here. And we also want to enable this group here. We're going to call this JB, for just born. That's the group that we created before. You can just select it there, in there. And then we also want to add in a pop wrangle, because if I take a look at our particles here, we want to have a couple of different layers, and these are kind of moving a little bit slow away from the origin. So I'm going to, again, enable this just born group, because I only want to add some velocity onto the particles as soon as they are born. I don't want to continuously add velocity to them. So we'll do v at v, and we'll do a times equals, and we can change this later, but I'm going to set it to like 10, and that should give us some much quicker moving particles away from the origin. You see they really fly away there, but don't worry about that because we're going to adjust that here in a little bit. So I'm gonna just make some more space here. We'll drop down a pop wind because we want to add in the noise to our particles so that they're not all moving in the same kind of way, in moving at the same speeds. So we're going to come down to our settings here and just up the amplitude. I'm going to set it to something really low. And same with the swirl size. I want those both to be pretty low, just because if you set them too high, they're going to really kind of blow out your particle movement and make it difficult to get something that looks good. Now you can play around with the roughness as well. I'm going to just maybe up that a little bit. And then we want to use these vex expressions. So one way to use these, or the way that you use these, is to affect these particle like attributes. So if we look at these, we have amplitude. If I hover over this, you can see that this parameter is called amp. So we can reference that in our vex expression by typing in amp. And now we're also going to use offset here. So we need to know what that one's called, and it's just called offset. So we want to change, starting off with our offset, we're going to change that based off our birth frame. So we'll type in offset, and we'll just do plus equals at birth frame. And now it's just going to give us a different offset for our noise. If I press play here, you can see we are getting some noise being applied to our particles, but we want to do a couple things with this. Number one, we want to turn this off as the particles start to slow down, which again, we're going to slow those down quite a bit here in a little bit. So we'll take an if statement, we'll do if, and then we're going to take the length of our velocity vector. So it's going to be the magnitude of that. It's going to give you a float value, so we'll compare that to another value. So we'll do length of at v, and we'll compare that to something really small, so at 0.25. So if our particles slow down below that, then we're going to stop affecting them with our amplitude, because as they get slower, we want our amplitude to kind of shut off here. So we'll do amplitude times equals 0, and that'll just turn that off as they start to slow down. Now, in order to actually have this do anything, we need to actually have them be slowed down. So the way we're going to do that is with another attribute wrangle, pop wrangle. Wire this up, and we'll do v at v, and we'll do times equals, v at v, and we'll do times equals, and we just got to multiply this by something lower than 1 to slow them down. So 0.975. And then we're also going to take the length of the velocity again, the magnitude of it, and we're going to compare that to a value. And once they get slow enough, we're just going to stop the particles altogether. So we'll do if at length, and we'll do our at v again. If that is lower than something like 0.001, then we're going to do at stopped is equal to 1. And that's just going to stop our particles. Now, I also want to just drop in a pop drag, just because pop drag just gives it a little bit of resistance there. So if I press play now, we get something to actually happen here. So we have our particles shooting out from the center, and then they kind of get their noise being added to them. And as they slow down, they eventually just stop altogether. So that's where this wrangle comes in. So without this, if I press play, you see that they just continue to move all over the place, and that's not what we want. We want them to actually slow down and stop. So we'll turn that back on. And then we need to do a couple of things. We need to create a couple of copies of this. So we're going to take our popnet here. Actually, we're going to take all of these and we're going to copy them. And we're going to do this again so we can all click and drag. We'll make 3 copies here. With this first one, I'm going to change the divisions up pretty high on this, maybe like 3,000. That's going to control how many points we're actually spawning here. And then for the second one, I'll do like 1,000. And the third one, we can just leave it at 100 here. So we want to jump into the second one here. Let's actually take a look at this one. We'll dive inside because we don't want them all to be accelerating away at the same speed here. So we want them to stop at different points. So we'll take our VOP or our wrangle here, And we're going to change this value to like 5. And that should be good for that. And then let's come to our third one and let's set this to, we can honestly just leave it at 1 or get rid of it altogether. And we'll see how that looks. So we do need to enable the trails though for these. So let's come back to our first one. We press play. You see, we just have our particles that are shooting away here. But we don't have any trails that are being applied to this. So we need to drop down a trail. And for this, we want to do $F -1 so that we get the same thing. Available $, let's see, $FF. There we go, $FF -1. So we'll get the frame that we're on and we're going to subtract 1 from that. So it's going to create a new particle basically every frame here. And we get something like this. Now we can drop down and add. After that, come to this polygons, do by group. Instead of all points, we want to do by attribute, and we'll type in ID here. And now we have our points that are being spawned here. Now, I also, since I'm in Solaris, I'm just going to show you some quick things that you need to do in order for this to display properly, because if we jump up to the stage context, you see that we get this type of like mangled strips that we got going here. So we can affect the size of these because sometimes these will be really, really large. So we'll drop down an attribute wrangle. And we'll do F at width is equal to something really small, like 0.003. And then also we want to store the name or a name for these because we want to actually come in here and be able to add different materials in the stage context. And so you need to give them a name attribute in order for that to actually work. So we'll do this inside of this wrangle. So we'll do int, we'll do value, create a variable, an integer variable called value. And we will convert our birth frame attribute, birth frame. And then we'll do s at name is equal to, and we'll use the sprintf function to print this into a name. And we'll call this maybe like emission underscore, and then we got to do this like modulo symbol and then a D. And this gives you, once you type in the value here, this gives you a attribute. It should give you an attribute. Let's see. Oh, I forgot my colon there at the end. So this gives you an attribute called name. Where is, here we go. So we call this one emission underscore 1. That's just going to append this value, that underscore, and then this modulo D, or the, yeah, that little symbol. I'm trying to blank on what it's called. But as we give this to our other pop nets here, just wire this one up and I look at this. If I come over to our name attribute, we are getting the same value because we're spawning it on the same frame. That's right. Okay. I forgot to change this. So we want to change this from the first frame to the second frame here. And then in this pop net, we need to change this impulse activation here to the third frame. I forgot to do that earlier. So now we spawn our particles there and I look at our name attribute. You see we have emission 2 there. So all these are going to have different names. So we'll do another one here. Now we can merge these together. Take all 3, merge them together. And then last, we just need to attribute promote that attribute. So we'll take our original name, which was the name attribute. We went from a point to a primitive because in order for it to split out in the stage context, if we look here, you see it needs to be a primitive attribute. Without this, If I jump back up, we only have one curve there. So we need to have this as a primitive attribute. Now, the one other thing that I did was just transform these. So you can do this up here. Actually, this one doesn't really need one, but we can do a transform here. And one here as well. And I just move these a little bit just so that the particles aren't colliding with each other. So we can just pull these forward. So something really small, maybe like 0.04 should work. And then we'll move this one forward like 0.06, just a little bit further still. So now if I look at this, we can even just render using Karma CPU. And you can see that we have our particles all being applied here in our viewport. And we have our trails and everything. It's rendering really, really nicely. So now all you have left to do is just assign some materials, which is pretty easy to do since we've broken these out as their own objects. You can use a, let's turn off this real quick. You can use a a material library, and then a material linker. And we see in our geometry tree here in the material linker, we can just drag these different types or these different curves into our material, and we can assign them that way, and it works really, really nicely. So that is a quick look at how we can create this type of effect inside of Houdini. It works pretty well and gives you a lot of control, just like it does in XParticles, but this is the Houdini version, if you will. And I think it's a pretty cool little effect there. So like I said, it did come from Insydium's video, or they're not the video, but they're like promotion on this. They're XParticles for Black Friday or whatever. So definitely check that out if you're a Cinema 4D user. I guess I've used it in the past. It's a very good plugin for Cinema 4D, but Houdini is the way to go. So this is how you do it in Houdini. But anyways, like I said, this project file is available on Patreon. If you'd like to grab it, you can do so on there. I also just released Humat, the utilities release for that, and that allows you to have some really nice tools to help build out materials inside of the new cops context in Houdini. Super, super powerful stuff in there. If you haven't taken a look at that, then definitely jump over and take a look at that. It is available on Patreon and Gumroad as well. Make sure you follow me on Gumroad for any future releases of different things on there. But anyways, thank you guys for watching and have a good day.